Hey guys, coming at you with another mind-blowing video about math. I have to say, I don't have a better introduction, so I'm going to stick with that. Alright, today we're going to talk about triangle similarity postulates. First, we're going to talk about what a postulate is. Then we're going to talk about the 3 postulates of similarity. Then we're going to do a handful of examples. Take a look at how we use them and why we use them. Okay, so let's take a look at the first thing. What is a postulate? A postulate is just a statement that's assumed to be true. That's the definition. You want to know what the definition is because the word postulate gets thrown around in a number of different math disciplines. So just understand that all we're saying, if we say the word postulate, it is a true statement. Okay, let's take a look at the 3 postulates of similarity. Alright. So the 3 postulates of similarity are angle, side, and side. Some of you guys may notice that side, and side has something to do with congruency too, and that is true. But in this case, we're dealing with similar triangles, not congruent triangles. So these look slightly different than they would if we were dealing with congruent triangles. Let's take a look at that. Okay, so here's how these postulates are used. There are reasons for being able to state why triangles are similar. I use that word very intentionally. So, quickly just thinking about what this is used for. Well, before we had things like AutoCAD and computers and all that stuff, if we were building something and we needed evidence that we were making 2 similar shapes, this was a method to do it. Think along the lines of ancient Greek and so forth and so on. And as a result of that, we get to teach it to you today. So let's take a look. Angle. At first glance, angle looks like it's the easiest one to prove. And it's not. I really believe this is the trickier one because most of the times these angles here are not listed or marked out for you. So as a result is you need to know your angles. You need to know vertical angles, alternate interior angles, alternate exterior angles, and corresponding angles. And that will provide evidence for you to use angle as a reason of similarity. If you can't find them, then you're going to have a very difficult time making a statement to back this up. Now we got side similarity. Well, that one is a little bit more straightforward, or it can be more straightforward, because we're just looking at the 3 sides. So I want to use side as a reason to prove similarity. Well, in order to do that, I need to prove that all 3 of these are proportional at the same scale factor. If you recognize that word from dilations, because similarity and dilations are very, very related. A definition for similarity could be a dilated figure, which really means that the sides are proportionally larger or smaller, but the angles are the same. So I have to test that. And in order to do that, what I'm going to do is I'm going to test all 3 sides and see if these are all the same value. The way I did that was I took the larger sides, paired them, the smaller sides, paired them, then the medium sides, and paired them. Now, all I have to do is make sure they're all the same value. The way I typically like to do that is just reduce the fractions. That's the easiest way for me to notice and the most clear cut. So this one here is 1/2, if my marker would write, 1/2. 6/12 reduces to 1/2. And 7/14 reduces to 1/2. Okay, so all of these, let me fix that so it's a little bit clearer. 1/2. There we go. So that means all three fractions are equal. They all reduce to the same thing. As a result of that, that means there's a set scale factor between these sides. So all three sides are changing by the same proportion. So as a result of that, I can make the statement that these triangles are similar by side, side, side. All right, next, I got side, angle, side here. Well, side, angle, side is saying that there's two sides and an angle included, or an angle in between them. It's important to recognize that if the angle was out here, and then I had my two sides, that is not similar. That's not side, angle, side. I need to have a side, angle, and a side. Side, angle, and a side in order for this to work. Then I also need to have my sides be proportional. So just like before, I'm going to test this and make sure that my sides come out to be the same. So what I did is I picked the two large sides, put them together, and the two small sides and put them together. And I'm going to reduce the fractions. So 1/2, 1/2 again. That means these are similar. Now, if you decide to convert these to decimals, let's be clear. This has to be 0.5 and this has to be 0.5. If this is 0.5 and this is 0.501, then they're not similar. They have to be exactly the same decimal. So you have to be careful with that. That is kind of the reason why I would push reducing fractions. Next, let's look at a couple more examples. Now this is slightly different than the way I usually do it. I put all three on one slide, but I want you to see the differences in them. So, here's how I would go about this. This first triangle here, I'm going to choose angle, angle as my best bet for proving that these are similar. I'm going to do that because I don't have any sides here. I don't have any anything labeled other than these crazy arrows. So let's take a look what I got here. Well, these arrows here mean parallel lines. Parallel lines. So as a result of that, I have a number of angles in here. I have the vertical angles in the middle, but I'll use them at this problem here. And I have alternate interior angles as a result of the parallel lines. So I have this angle and I have this angle. I also have this angle here and that angle there. So I can make the statement here that these triangles are similar because of angle, angle. And I could back that up by saying that these angle lines here are parallel. So I could say angle, angle. Okay, next, let's take a look at this one. Well, this one here, I only have two sides listed, two sets of sides. So I'm going to try for side, angle, side. Side, angle, side is what I'm going to try for. And the first thing I notice is that I got these angles right here. Angles that cross like this are opposite each other are called vertical angles. So I could say that I have a set of congruent angles. Now I have to test the sides. Well, I'm going to pair them up. This is the short side to this short side, so 8/12. Then this is the short long side to that long side, so 21/27. You don't always have to put the little guy as the numerator. It's just a preference. Now I'm going to use my calculator this time because just in case I'm not comfortable with reducing fractions. So 8/12. Okay, that becomes 2/3. Then the next one is 21/27. 7/9. So these are not similar because my fractions are different. So that means these sides are not proportional. So I don't have these sides. So as a result of this, as a result of these, I have to say not similar. Okay, I don't have similarity there. All right, next. So this gets a little tricky. Here, I have two triangles, one on top of the other, basically. This is the little triangle, then I have a large one, kind of moving around it. So what I want to do is I want to separate those triangles before I do anything. So let's see. The little triangle is 33, 27, and 30. The large triangle is the sides of me adding this together. So I know that the bottom is 100. Let's add the top one. So now that scribbly little number there, that's 77. So 33 plus 77 is 110. That makes this 110. So 110 here. Then 27 plus 63 is 90. This is where a calculator comes in handy, because the first time I've done this problem, I almost labeled that 100. It's easy to make a little adding mistake, so be careful with that. Now what I'm going to do is I'm going to label my sides. So this is the large side, that's the large side. This is the small, small, and that's the medium, and that's the medium. So let me make my fractions. 33 over 110 is 1. Then 27 over 90 is the other. Then 30 over 100 is the last. And let me check my fractions here. Well, 30 over 100 reduces to 3 over 10. 33 over 110 reduces to 3 over 10. 27 over 90, I'm not sure, so I'm going to use my calculator again. So I'm going to say 27 over 90, and that's going to give me 3 over 10. So that means that my sides are all proportional. So I could use side, side, side as a statement that is the reason why these two triangles that are in here are similar. So I could say side, side, side. And that's it. It takes a little bit of practice, definitely with these guys and these guys. So that's the video on the triangle similarity postulates. I hope you guys found this video helpful.